Hello guys, how are you? This is Adnan. I am mechanical rotating equipment engineer. Today we will learn about the difference between dynamic and positive displacement pumps. Before I start this video, I would like to please subscribe my channel, and if you like this video, please click on the like button. Okay, so are you ready to start? Okay, so let's move to next slide. So what is pump? So pump is a mechanical device used to transfer liquids from one point to other by imparting energy supplied by a prime mover to the liquid. The prime mover can be an electric motor, an IC engine, or a steam engine or turbine. You can see in this picture, so this is the mechanical part which is called the pump. Okay, and it is basically driven by some prime mover, which you can see here in this diagram is electric motor. So what happens that this electric motor, once it rotates, both are connected by a shaft, and this shaft is connected with the impeller which is inside this pump, and once the impeller rotates, it produces the energy, and this energy is then transferred into the process fluid which is coming into this pump, and then this is the discharge connection where the fluid goes to the process system. So basically there are two types of pumps. First is positive displacement, in which the energy is imparted to the system through the positive through the displacement of the volume, and then the other type is rotordynamics, which is also called the centrifugal, okay, which creates the energy through the rotation of the impeller or uh, vanes or the propeller, as we have learned in the previous slide. So in the positive displacement pump there are multiple different types. It may have reciprocating pump, it may have control volume pump, it may have gear type, it can be twin screw, single screw pump, it can be vane type. And in rotordynamic there are multiple pumps like centrifugal pump, which are this you can see in this diagram, end section pump, then vertical inline pump, and so on. There are different, we will learn different types of pump in our next video. Okay, so what is the basic difference between the rotordynamic pumps and positive displacement pump? So for rotordynamic pumps, which are also the centrifugal pumps, energy is imparted to the pump fluid by means of rotating impeller, propeller, or rotor. Then these rotordynamic pumps are centrifugal pumps. They are not fixed flow devices, and there is a variable relationship between the flow and pressure, which is normally seen on the performance curve. And these pumps are basically uh, they are basically acting against a high system pressure, generates less flow. So if the pressure will be high in the system, then the flow will be the less. Then the pressure is basically developed by the kinetic energy transformation, okay, and then it's converted into the pressure energy. Rotordynamic pumps are suitable, okay, in the system where which requires basically high flow and low pressure pump. And there is another advantage of these centrifugal pumps, that since they have less parts and there is less wear and tear, so the cost of the overall pump is low than the reciprocating or positive displacement pumps. However, there are fewer disadvantages. for the centrifugal pumps, that they are not basically well suited for the high viscous fluids, and their efficiency decreases when the viscosity increases. That's why they are normally not suitable for the fluids having viscosity over 850 centi-stroke. And the second main disadvantage of this pump is they can only handle the liquids and they cannot entertain any gas, and that's why they are not self-priming type, and they are normally avoided for the process fluid which has uh, gas volume fraction higher than the 15%. Okay, next move to the positive displacement pump. As we already told that this energy is imparted to the pressurized fluid with collapsing volume by decreasing volume action with each piston stroke or shaft rotation. Then these pumps are basically fixed displacement volume device, and they basically, in that, the flow is directly proportional to the speed. The flow is not changed. These are called the constant flow device, constant flow pumps, and the pressure is developed in the system by the resistance to the flow. Then these pumps are suitable when there are fluid is high viscous, okay, and their efficiency increases with increase in viscosity. As we know that centrifugal pumps are high flow low pressure device, but here they are used, positive displacement pumps are used in a system which requires basically high pressure low flow pump, and these pumps are self prime in contrast to the positive displacement pumps, and they can basically handle a small amount of gas as well, and they require basically less NPSH requirements. Then these pumps are used where precise flow or metering is required. So these were the advantages for positive displacement pump. On the other side, there are some disadvantage for this pump as well. So one of the key disadvantages that these require, if this can over pressurize the system, since these are continuously increasing the pressure, okay, if the discharge is close, then your pressure will keep on rising, and in order to avoid that, it will require a safeguard system like relief valve. So this is relief valve is prime requirement for the systems containing positive displacement pump. So let's move to these videos which will basically tell you about the basic functions of centrifugal and reciprocating pump. So let's start it.
Centrifugal pumps are the most preferred pumping devices in the hydraulic world. In this video, we will have a conceptual overview of working of centrifugal pumps. At the heart of the system lies the impeller. It has got a series of curved vanes fitted inside shroud plates. The impeller is always immersed in water. When the impeller is made to rotate, it makes the fluid surrounding it also rotate. This imparts centrifugal force to water particles, and the water moves radially out. Since rotational mechanical energy is transferred to the fluid, at discharge sides of impeller, both pressure and kinetic energy of water will rise. At suction side, water is getting displaced, so a negative pressure will be induced at I. Such low pressure helps in sucking fresh water stream into the system again, and this process continues. This is the reason why priming is important for centrifugal pumps. If no water is present initially, the negative pressure developed by rotating air at eye of impeller will be negligibly small to suck fresh stream of water. Impeller is fitted inside a casing, so the water moving out will be collected inside it and will move in the same direction of rotation of impeller to the discharge nozzle. Here you can note one specialty of casing. It has got increasing area along the flow direction. Such increasing area will help in accommodating newly added water stream and will also help in reducing exit flow velocity. Reduction in flow velocity will result in increase in static pressure, which is required to overcome resistance of pumping system. Here you can see more details of vanes inside impeller.
Okay, so as we already have discussed that the basic function is that the centrifugal pump is designed in such a way that the kinetic energy is converted into the potential pressure energy. So this is how this centrifugal pumps works, and this is because of the impeller and its casing design. Now we also let's have a overlook on this positive displacement pump.
Most pumps can be classified as either a centrifugal or positive displacement pump. Positive displacement pumps specifically work by drawing fluid into an expanding cavity on the inlet side and then transferring that fluid to a decreasing cavity on the outlet side where the liquid flows out. Unlike centrifugal pumps, positive displacement pumps maintain fluid velocity regardless of inlet pressure. Positive displacement pumps come in three common types designated by the mechanism used for fluid transfer: rotary, linear, or reciprocating. Rotary positive displacement pumps have internal gears. Linear types use rope pumps and shade pumps. In reciprocating positive displacement pumps, one or more diaphragms move fluid while valves direct the fluid to the proper location. Reciprocating diaphragm pumps have many possible applications because of their good dry running capabilities, high efficiency ratings, self-priming capabilities, and their ability to accommodate applications involving highly viscous liquids. For more videos like this, visit designworldonline.com.
They are backward curved vanes with state-of-the-art eye configuration. This vane is extracted.
Okay, so that's all from my side. So I hope you have clearer understanding now for the difference between the centrifugal and reciprocating pump. If you have any question, you can write in the comment section and we will try to address it. Thank you very much. We will meet in the next video. Okay, bye bye.